Hello everyone, welcome to Digital Electronics Virtual Lab. Today our topic is counter designing. So first of all, we will discuss some theory portion of the counter. Major of the theory portion is already covered in the theory classes. So here we are implementing basically synchronous up counter and asynchronous up counter with the help of JK flip-flop. Okay. So in broadly, we can say that we can divide counters in two categories. First one is asynchronous counter and second one is synchronous counter. The basic application of the counter is to count clock pulses, clock signals. Okay. So if I am interested to count a number or we can say number of persons who are entering in the room, so 1, 2, 3, 4, 5, 6, that is basically up counting. If we are interested to count in the reverse mode like 9, 8, 7, 6, 5, 4, 3, 2, 1, so this is basically a down counting. Okay, so there are again two categories in asynchronous counter and synchronous counter, that is synchronous up counter, synchronous down counter, asynchronous up counter and asynchronous down counter. So here we are implementing asynchronous and synchronous up counters. Okay, now so we have already covered the asynchronous, the main difference between asynchronous and synchronous circuits. So here we are implementing a 4-bit asynchronous up counter. Okay, and we are implementing it with the help of JK flip-flop. So this is the basic circuit diagram of the asynchronous up counter. So the output of previous flip-flop, this is JK flip-flop, the output of previous flip-flop, that is Q, is connected to the clock of the next flip-flop. Okay, so the previous flip-flop is this one and the output of this flip-flop, that is Q, is connected to the input of the next flip-flop. In the same way, this flip-flop is the previous flip-flop for this flip-flop, and for this flip-flop this will be the previous flip-flop. Okay, so the output of this flip-flop is connected to the clock, output of this flip-flop is connected to the this clock. Okay, so in theory portion we have covered that if we are interested to design down counter, then we have to apply the negative output, means Q bar. We have to apply Q bar to the input of the clock of the next flip-flop. Similarly, Q bar of this flip-flop will be connected to the input clock of this flip-flop. The output Q bar is connected to the input clock of this JK flip-flop. Okay, so this is the major difference between up counting and down counting. Okay, now whenever we achieve a portion of a clock, so basically there are four major parts. We have already covered four major parts. The first one is the positive level, second is the negative level, then positive edge, and then negative edge. Okay, so whenever a flip-flop or we can say the counter is working in the negative edge, so whenever the negative edge part of the clock occurs, then only the value of the outputs of a particular flip-flop will change. Okay, so on that basis the particular outputs Q0, Q1, Q2, Q3 will change their values, and this value will read by the output circuitry, that is Q0, Q1, Q2, Q3, and then it will be counted, or you can say it will be assumed as the counting part, means 0, 1, 2, 3, 4, 5, 6, 7, 8, like this. So for this 4-bit counter, we can count from 0000 to 1111, so 0 to 15. Okay, so this is basically the working of a brief. I have discussed the brief portion, or you can say briefly the working of the asynchronous counter. This is the timing diagram. you can say. Okay, so this is basically the timing diagram, and we are using JK flip-flop. Okay, so in the case of JK flip-flop, we are using the condition J equal to 1 and K equal to 1. So you can see here that J and K both are connected to the high input. Again, for second flip-flop, J and K are connected to the high input. So this is basically a T flip-flop. When J equal to K equal to 1, it will be treated, or it will be um, designed or used as T flip-flop. Okay. Now move to the simulation part. Okay, so just click on this simulation part. Basically, counter is a very interesting circuit of digital design part. So how to design asynchronous up, asynchronous down, synchronous up, synchronous down, mod and counters, you can say ring counter, twisted ring counter, and up down counter means a circuit in which you can perform up counting as well as the down counting. Okay, so just click on the asynchronous counter. So this is basically the circuit diagram of 4-bit up counter. Here we are using two ICs of JK flip-flop, and in individual IC7476 is basically a JK flip-flop, dual JK flip-flop. So there are two JK flip-flops in IC7476, and the same way the second IC is this one. So basically we are using 1, 2, 3 and 4 JK flip-flops for the implementation of 4-bit up asynchronous counter. Okay, so all the connections are already provided to us. We have to check we have to check the outputs by applying the number of clocks. Okay, so whenever we click on this clock, this is negative triggered clock. As I said earlier that there are four parts of a particular clock. So basically this counter, or you can say this JK flip-flop, is working on with the negative triggered flip-flop. As you can see that this negative sign, this circle is basically representing the negative part of the clock. Okay, so negative triggered clock is basically used to perform the operation of this particular 4-bit counter. Okay, so first of all, we have to go through the instructions. So on the left hand side there is a list of instructions which we have to follow for the simulation of this particular counter. So first one is the press switch to supply 5 volt. So you can see that we have to apply a voltage of 5 volt for the operation of this counter. Second, the green is the on state of the switch, and red color is showing the off state of the switch. Okay, now press counter button to start the counting simply. Then LED in off state is like this, that like Q3, Q2, Q1 and Q0, and LED in on state will glow will be glow with red color. Okay, now repeat these steps as we are interested to count from 000 to 1111. So we have to push or click on the clock portion of the clock of the circuit. Okay, so let's start. So first of all, just click on the power supply. Okay, now click on this negative triggered clock. Okay, so this is the first, means the we have applied a clock, and the first part of the, or you can say the first clock achieved or is connected to the circuit of 4-bit counter, and we will get the particular output at Q3, Q2, Q1 and Q0. Okay, so this is basically the a sequential circuit, okay, in which the clock, on the basis of clock, we will get particular outputs. Now, when I again click on this clock, so I will achieve 0001. So the output is 1. Now on the next clock, the output is 20010. Okay, so by clicking on this clock, we will get a particular output. Okay, so we can achieve it up to 15. So like 14. So next, just check your output, that is 1101, and after one more click you will achieve 1110, and the next clock the output is 1111. Okay, and after one more click it will be reset. Okay, so the circuit is designed in such a way that after 16 clock pulses you will get, your circuit will be reset. Okay, so this is the output. So simply by clicking on this you can check that on a particular clock what will be the values of 4-bit asynchronous counter. Okay, so with the help of in our theory classes we have already covered it with the help of waveforms. We just monitored the how the values of a particular flip-flop is changing from the previous value, how they are shifted with the help of clock. So all these functions, all these monitoring we have already covered in our classes. This is basically the simulation part. We are just checking that are we getting the values after each clock or not. So yeah, we are getting the values from 0000 to 1111. Okay, so this is basically the working and the simulation of asynchronous up counter. And you please remember that what is the difference between asynchronous and synchronous. In asynchronous circuit the output of previous flip-flop is connected to the clock of the next flip-flop, while in the case of synchronous counters all the clocks of all flip-flops are connected with a single clock. So a single clock is controlling the functioning of all flip-flops. Okay, in the case of synchronous counter, and here we are implementing asynchronous up counter. So the Q output, Q output will be connected to the clock of the next flip-flop. Okay, so I hope with the help of this simulation you will get a clear picture of the working of the 4-bit counter. So thanks for watching this video. I think this is sufficient for today's simulation part of the 4-bit counter. In next lecture we will cover 4-bit synchronous up counter. Okay, thank you.